Now we're ready to begin chapter 12. So we'll do the first lesson, which is multiplying and dividing expressions with common bases. In other words, the large number beside the exponent is what's going to be the same, the base. So we're going to be doing a few different things. The first thing that we're going to look at is products. This means when we multiply. If we're multiplying exponential expressions with the same base. So if we're talking about 5 to the fourth power times 5 to the third power, we have the same base. 5 is the base. So what 5 to the fourth power means is using 5 as an exponent 4 times, 5 times 5 times 5 times 5, and we're multiplying it by 5 to the third power, or using 5 as a factor 3 times. So as we can see, if we just regroup this, we have 1, 2, 3, 4, 5, 6, 7 factors of 5. So 5 to the fourth power times 5 to the third power is equal to 5 to the seventh power. That's the same result as if the exponents were added. So the product rule for exponents, and this of course is when we multiply, we'll add the exponents and keep the common base. Remember, we have to have the same base. Otherwise, we can't use this rule. So here's some problems that we'll practice with. 4 to the second power times 4 to the fifth power would be 4 to the 2 plus 5 would be seventh power. And we can just leave these in exponent form. If we have a variable for our base, x to the third power times x to the second power, we're still going to have a base of x, and we're going to be adding 3 plus 2, so x to the fifth power. This is really pretty simple. You just have to remember the rule and be sure that you're multiplying things that have the same base. So we have y to the third power times y, and we know that this would be y to the first power. We just don't write that. So when we multiply these two, we get 5 to the 2 plus 1 would be third power. So now we have 3 factors, and they all have the same base, so that's good. We can use our rule. We have x to the third power times x to the second power times x to the seventh power. So we're going to add 3 plus 2 is 5, and 5 plus 7 is 12. In the next example, we have negative 5 taken to the seventh power times negative 5 taken to the eighth power. And you can see from the parentheses that our base is negative 5, and we need to enclose that in parentheses. Otherwise, we'll have something different. Then we're going to add the exponents. 7 plus 8 would be 15. Negative 5 taken to the 15th power. Now, we've done these before where we've had variables and we've had constants. So we're going to first take a look at is it going to be positive or negative? Well, the signs are different, so it's going to be negative. Now we're going to multiply 2 times 3, which is 6. And we're going to multiply x squared times x to the fifth, and we're going to use this rule. We have the same base, and we're going to add the exponents. 2 plus 5 would be 7. This next one, again, we can rearrange the factors. So we'll multiply the x's, and then we'll multiply the y's. So the x's, we have 3 and 2 as our exponents, which would be x to the fifth. Then we have y times y to the second, and we know this is y to the first, so we're going to add the exponents. 1 plus 2 would be 3. We have one last example. Again, we have a negative times a positive, so we know that our signs are different, so the answer will be negative. And first we can multiply the constants. We have 3 times 1, which would be 3. Now let's do the a's. We have a to the 7th and a to the 1st, so we'll add those exponents. And next we'll look at the b's. We have b to the 4th and b to the 9th, so that would be b to the 13th. So this is really fairly simple if you know the rule and you know when to apply it. One caution we have to do is to differentiate in our brains the difference between adding and multiplying terms. So we've got a couple of examples here that will help us. Remember when we add, if we add 5x cubed plus 3x cubed, these are like terms, so we can add them, and we just add the coefficients. So 5 plus 3 would be 8, 8x cubed. Here's another one. We have 7x squared plus 7x plus 4x squared. These are not like terms, so we can't combine them. So we end up with the very same thing that we had to start with. Now, if we're multiplying these, we're going to multiply 5 times 3, which is 15, and then we'll multiply x cubed times x cubed, which will be 3 plus 3. We'll add the exponents, which is x to the 6th power. This is also multiplication, so we'll multiply 7 times 4, which is 28. Then x to the 1st times x to the 2nd. We'll add these exponents. We have x to the 3rd. So it's really a different process between addition and multiplication. So be sure you have those straight in your minds. So that's multiplication. And now we're going to talk about the quotient rule. And the quotient rule that we use when we divide, when we're in division. And we can see here that if we have x to the 5th, we have 5 factors of x on the top, and x squared on the bottom are 2 factors. So those cancel out, and we're left with x to the 3rd. And that is the same result as when the exponents are subtracted. So 5 minus 2 would be 3, x to the 3rd. So the quotient rule, when the bases are the same, and we have to be sure they are, we subtract the exponents. And this is just our generic model for that. B to the m over b to the n, you see we have the same base, and we just subtract the exponents. So here we have the same base, and now we're going to subtract the exponents. 7 minus 2 is x to the 5th. Here we're talking about 4 as the base, and we're going to subtract the exponents. 6 minus 3 is 3. And we can just leave these in exponent form. We don't need to go ahead and expand this. This we couldn't unless they told us what x was, but this we could expand. It would be 64, but we can just leave it in exponent form. I think that's what the directions in your book tell you. Okay, we've got 2 exponential numbers or terms in our division problem. We know this means divide. Our base is -3, and we'll subtract the exponents. 5 minus 2 would be 3. And again, we're just going to leave it like that. Okay, this next one, we've got a couple of different variables and a couple of same variables, same base, but different ones in the. So we'll start dividing. 2 divided by 1 is 2. X to the 5th divided by x to the 1st would be x to the 4th. We're subtracting the exponents. Y to the 2nd divided by y to the 1st. We'll subtract the exponents, and we end up with y or y to the 1st. You can write the 1 if you want to. But that's our first lesson in Chapter 12.